So I know this homework is tough. I'm going to try to do some of these problems. I hope it helps. I know everybody has slightly different numbers, and so there's a few ways to make small errors that will just make WebAssign consider the whole thing wrong. So this is, what is this? This is x is equal to 2 sine theta. If you wanted to do 2 cosine theta, that would work also. Then dx is equal to 2 cosine theta d theta. And I'm going to make this big. All right. So this becomes the integral of 4 sine squared theta times 2 cosine theta d theta. Sorry, my handwriting is bad. I just started. I think it'll get better as I get used to this. And then the whole point is that this bottom thing becomes 2 times cosine theta. All right. So this is just the integral of 4 sine squared theta. D theta. And you should be able to do it from there, or even just look up the answer. So I'm going to consider that one solved, right? And so let's look at this one, right? So we've got the integral of dx over the square root of 16 plus x squared. And let me just double check that that was right. Yeah. So the substitution here is x equals 4 tan theta. And then dx is equal to 4 secant squared theta d theta. So this becomes the integral of 4 secant squared theta d theta divided by, this becomes 4 times secant theta d theta. Or sorry, just secant theta. Alright, so this is just the integral of secant theta d theta. Alright, and you should be able to do that, and in the worst case you can just look it up. Alright, so next. Okay, so the next problem is, whoops. Sorry if you can hear my washing machine. The square root, this one looks harder. X squared minus 16 over x dx. So the substitution for this one is x equals 4 secant theta. So that means dx is equal to 4 secant theta tan theta d theta. So this becomes the integral of, the point is that the radical turns into 4 tan theta. And then dx becomes, so there's, I'm going to say tan squared because of this tan here. And times another 4 and times secant theta d theta. I think I hear my daughter pouncing out. Oh, that's my dog, my wife. And we have on the bottom 4 secant theta. All right, so let's do some cancellation. 4 secant theta and 4 secant theta go away. And you have the integral of 4 times tan squared theta d theta. So this is a nice little problem. I'll let you do it on your own. This one is not completely obvious, but here's a hint. Just convert to secant. What else? I want to do this. Go. Alright, so this one, didn't we do one of these in class and it was like god awful? These have been pretty easy so far. So we've got 32 dx over x squared square root of x squared plus 36. So the substitution is x equals 6 tan theta, dx is equal to 6 tan theta d theta. 6 tan, that's crazy. What am I even saying? 6 times secant squared theta d theta. So this becomes 32 times the integral. On the top you get 6 secant squared theta d theta, and the bottom becomes 6 tan squared theta for that x, and then the stuff under the radical becomes 6 times secant theta. Alright, so let's work on this one. You get some cancellation, so you can cancel a 6 and you can cancel one of these secants and you get 32 over 6. And now you've got you could write it like this. How about cotangent squared? So instead of writing tangent squared in the denominator, I'll just write cotangent squared in the numerator. And you've got one secant left there. So this is secant theta d theta. Alright, so I don't immediately know what to do. I'm going to convert into sines and cosines in case that gives me any ideas. And at the same time we can simplify this. So this is 16 over 3. And in terms of sines and cosines, this is, yeah, this is good. So you've got cosine squared theta, because we're going to get another cancellation, over sine squared theta times 1 over cosine theta d theta. So rank. And this becomes 16 over 3 times the integral cosine theta over sine squared theta d theta. And now it's obvious what to do. You do u equals something. And I know the crickets always chirp when I ask this in class, but if you really don't know, you're in serious trouble. Let's go to the next problem after that creepy remark. Is there any problems left? Oh, lots of writing here. So this problem is all about the triangles. Let's make a new page. Alright, so let's just I'll make this one always on top. Sorry. Stupid thing. Frustrating. Okay, so I'll just split the screen again. Alright, so we're supposed to match these things with the equivalent non-trigonometric function. So let me just do d. Let's look at d. I'll just do a couple of these. So d says that we have sine of tan inverse x over 4. So what I'm going to do is I'm going to draw a triangle and then just try to sort of feel my way through here. So from this tan inverse, I'm guessing that the original substitution was something like x over 4 equals tan theta. So that means that this side is x and this side is 4. And that means this this side is the square root of 16 plus x squared. Okay, So notice that tan inverse of x over 4, because of this equation, is just equal to theta. So this, the original question, is just the same thing as sine theta. And we can just read off sine theta here. It's opposite over hypotenuse. So x over the square root of 16 plus x squared. And if we look in the list, it shows up as number 3. So all of these problems work like that, and you can do the rest. So I think there were only 12 problems, right? 13 problems. Let's see about this one. Yuck. Should we do it? Let me just shove this stuff out of the way. And I've got minus 6 to the times t to the 5th power over the square root of t squared plus 2 dt. So I do t, I think we did this one in class in at least one section. This is the square root of 2 times tan theta, and then this turns into negative 6 times, oh my god, this is that really awful one, 2 to the 5 halves times tan to the 5th power theta, and then dt is equal to the square root of 2 times secant squared theta. So we've got times square root of 2 times secant squared theta. Alright, and now the point of the substitution is that the numerator turns into the square root of 2 times secant theta. And we get some cancellations, and one of these secants goes away. So the integral becomes negative 6 times 2 to the 5 halves times tangent to the 5th theta times secant theta, and I forgot to write d theta up there, and also right here. Oh, this pad is starting to feel very scratchy. Okay, so now what? We ask if we can do anything simple, like can I substitute u equals tangent? No, that doesn't work. Can I substitute u equals secant? No. Well, no, that doesn't work. So what if I try the trick where I feed out one of these? So I could, yeah, that works. Okay, that's what we did. So we do negative 6 times 2 to the 5 halves and turn this into tan to the 4th theta times tan theta secant theta d theta. And now the whole point is that this can be, oh, I didn't manage to change color, sorry. This can be du if u is equal to secant theta. I don't have any secant thetas, but because this is an it's because it's an even power of tangent, I can turn these into secants. So this becomes negative 6 times 2 to the 5 halves times secant squared theta minus 1 squared times tan theta secant theta d theta, and then you just do u equals secant theta, and it's an easy problem after that. Typing the answer in is a real bastard. Remember to do plus c. So since I've, already started the video and everything, is there anything else? I don't think so. I think all of these are pretty normal. It's a normal one. Is that a normal one? Yeah, that's a normal one. That's a normal one. Pretty normal. Actually, secant cubed is really hard. You should try to do it yourself, but then you might have to look up the answer. Or follow the example that's given in the book. So I'm going to stop the video. Good luck.